Hi there. Recently, I've spent some time building emulators. While doing this, I've noticed that some things are harder than they really need to be. In this video, I want to describe an idea I have to help accelerate the understanding of complex integrated circuit chips. There are three main challenges while developing an emulator. From easiest to hardest, these are 1. Implementation. Once you know what to build, implementing these rules correctly in software. If you have a perfect specification of the system, implementation is usually a breeze. Number 2 is testing. When you're learning about a system, you need to develop tests in order to better understand the functionality of the system. Observing the results of these tests helps improve your knowledge. And finally, 3, the hardest, is producing the specification. Given the results of the series of tests that you've run, you create an unambiguous specification that completely describes the functionality of the system. And it's actually impossible to create a good spec without a good means of testing. Fortunately, I think we can make testing easier. My idea is to build a platform to allow building and running tests against various integrated circuit chips. The lab that I'm planning on building will have a collection of chips. Each chip can be interacted with in various ways, and then you can observe how it responds to the inputs that you provide. I'm planning on building a rough first version based around the 6502. I think the 6502 is a good starting point because 1. I'm already familiar with it from existing emulators. 2. The chip is very well documented. Modern 6502 vendors actually provide an implementation of the chip in a hardware description language. This sort of represents the same logic that they would use to actually have the chip produced. This gives us an easy-to-use reference when tracking down any issues. And finally, 3, it is a fairly simple 8-bit chip running at a modest speed. This means that certain electronic issues, like signal integrity, should not be much of a problem. Here's a rough outline of what I'm thinking of right now. I'll definitely describe this in more detail as I actually work on building this. The rough plan is to do something like JTAG plus an online Linux machine plus a web interface. JTAG is a protocol or system that is usually built into newer chips, such as ARM. It allows something called boundary scan, which is the setting or reading of each of the values off of the pins. You can set a pin in order to send something into the chip, or read a pin in order to see what the chip is outputting. The Linux machine that it is connected to will be running a web server that allows people to interact with it, and will also contain a driver to communicate with the JTAG hardware, which talks to the chip. The web interface will let you see which chips are available, and also specify and run the tests. Right now, I have 2 types of tests that I want to support with this system. Most primitive, but also most flexible, is the ability to specify waveforms. A waveform essentially describes a series of steps and the desired inputs at each step. This gives complete control of the chip, but may be too level depending on what you are interested in testing. In the upper right of this slide, we can see kind of a visual representation of a waveform. This is a screenshot from an open source program called GTK Wave. One step up would be supporting machine code or assembly language. If you can provide a compiled program, the system should be able to automatically generate the waveform which would be equivalent to running the provided program. For chips that are essentially CPUs, this should provide a good level of abstraction for testing. And on the bottom right of this slide, you can see a little snapshot of an assembly language program I had written for the sound chip in the NES. Both of these test types assume only digital signals for the chip. In the future, I might try adding analog support to support things like testing of sound chips, but initially, I'm assuming just digital. And that's it for the introduction. Let me know if you have any ideas or comments on this proposal. I'm planning on making both the hardware and software available under a free software license. Additionally, I'm planning on making the lab available for anyone to use. The rest of the videos in this series will document the development of this actual physical system to support the 6502. And that's it. See you on the next video.